Here we are on page 11, solutions to numbers 5 through 16. So number 5, this thing has three terms. We first checked, can we pull out the greatest common factor at all? We can't, there's nothing common there, but this is three terms where the leading coefficient is just 1, so this breaks down. X squared plus 7x plus 12, and just have an x and an x, and we've got what times is together to give you 12 and adds together to give you 7. That would be a 3 and a 4. So there we go. Number 6, m squared minus 4m minus 12. Again, nothing as a greatest common factor will come out, so we just need to find two numbers that times together to give you negative 12 and add to a negative 4. That is an m minus 6 and an m plus 2. Number 7, x squared minus 10x minus 24. We've just got to find two numbers that times to negative 24. I'm going to write out the factors of 24 out here. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are the factor pairs. Now you'll notice that if these two were both negative, they would add to negative 10, but they don't times to a positive 24, so that cannot be the pair. Here we have a negative 12 and a positive 2. Those are the two that work. So x plus 2, x minus 12. And yes, of course, you can take this factor, x minus 12, and switch it with the x plus 2, and that's perfectly fine. Number 8, x squared plus 33x minus 40. Let me see, the factors of 40, 1 and 40, 2 and 20. 3, no, 4 and 10, yeah, and 5 and 8. Now this is a negative 40, so these two have to be opposite signs. Just like that up there was a negative 24. Opposite signs, and adding to a positive 3 would be those two right there. So we get x minus 5, x plus 8. And there we have it. Number 9. X squared minus 9x plus 18. So things that can multiply to 18 are 1 and 18, 2 and 9, 3 and 6. 3 and 6 add to 9, but it's a negative 9, so we've got to make sure we have an x minus 3 and an x minus 6. Notice, if these were opposite signs, they would times to a negative 18. So we've got to hit both multiplying to positive 18 and adding to negative 9. Number 10. A squared minus 21a minus 24. Ooh, here's our minus 24 listing out. These two would add to a negative 23, negative 10, negative 5, and a negative 2. None of them will add to negative 21. This guy is prime. He does not factor. We cannot factor him, and that's how we know it, right there. Number 11. 144x squared plus 168x plus 49. Ooh, yuck. That guy, this guy just has 7 and 7, and 7 doesn't go into this at all. That's 12 and 12, which is made up of 2s and 3s, so we're not going to get any common factor out of there. So here, oh, we do recognize that number and that number as perfect squares. So I'm just going to go out on a limb and say it's 12x plus 7. 12x plus 7. Also written as 12x plus 7 squared. Let's see if it works. 144x squared. Just make sure the middle term comes out. This is 84x, and that's 84x. So double 84 gets you 168. Check. There's our answer. Perfect squares will save us a little bit of time if we can see them. Number 12. 3p squared minus 363. And what do we get here? I think we can pull a 3 out of that. Always check to see if we have the greatest common factor. That's p squared minus 121. Ooh, 121, that's one of those special numbers right there. That's a perfect square. So this is a difference of squares, 3. And then we will get p plus 11, p minus 11. Let's make sure these guys are conjugates, so when they multiply we have no middle term coming out. difference of squares. And then make sure that 3 sits out there in front. Number 13. 16x to the 4th minus 81t to the 4th. Is there anything common? Let me see, 16 is made up of 2, 2, 2, 2, and 81 is 3, 3. Ah, so these are perfect squares indeed. So we would get 4x squared minus 9t squared, 4x squared plus 9t squared. And then this guy is a difference of squares. This guy can't go anywhere because you have a sum of squares. That's going to be prime. We can't go anywhere with that. But this guy will break down even further into 2x minus 3t, 2x plus 3t, and then that one just sits there, 4x squared plus 9t squared. And there's number 13. Number 14. 2 terms. Can we pull out something common? Yes, there's an 8 and an x in both of those. So we could do 8x, and we get 9x squared minus 1. This is now a difference, a subtraction of 2 perfect squares. So this is going to break up into 3x plus 1, 3x minus 1, and then that 8x comes and sits right in front there. Number 15. So here we have 8x squared minus 24x plus 18. Is there anything common there? 2? I think a 2 is all we've got. So if we take out a 2, we've got 4x squared minus 12x plus a 9. Oh, look at that. These are some special numbers here, a 4 and a 9. Those are perfect squares. Let's see if it breaks up into, let me see, that's 2x and that's 3 and 3, but we'll have to have a minus. Let's just a shot in the dark see if 2x minus 3, 2x minus 3 is what works here. That's 4x squared, and that's going to be plus 9. The middle terms are going to be minus 6x. 2 of those is minus 12x. Look, we got it. And then that 2 comes down. So we've got 2, and we have 2x minus 3 times 2x minus 3, or we can just write that as squared. And number 16. 1 minus 9z squared. So this is a difference of a square and a square, so 1 minus 3z, 1 minus plus 3z.